Hey guys, welcome back. And today we're going to be doing product and quotient rule, the next two rules in calculus. And this is going to be very interesting actually because we're going to be deriving the product and quotient rule just like before with the power rule. And so let's start with the product rule first. What do you remember about the product rule? So we define a function y as uv where u and v are functions of x. So they're basically u of x and v of x. And so now what we do is we want to find dy by dx. By the formula we know this is u v dash plus v u dash. Or you can also write it in the dx form, which is u dv by dx plus v du by dx. And so how do we actually derive this? We're going to look at it now. So first of all, we have y equals uv. Now, let's assume we don't know the power rule. What can we do to find dy by dx? So remember there's a multiplication in the middle. Now we don't want a multiplication because we don't have the product rule. So now what we do is we remember there's a function called the natural log. So ln of any multiplication ab is ln of a plus ln of b. This is one of the key rules in logarithms, and we're going to use this by taking the ln of both sides. So we take the ln of this and the ln of that. So what we get is now ln of y equals ln of uv, which is then ln of ln of y equals ln u plus ln of v. And now we have an addition in the middle, which we can easily differentiate. We can just differentiate this function first and then this function next. And so now what we want to do is differentiate both sides. So we get 1 over y equals 1 over u plus 1 over v. And we just say 1 equals y over u plus y over v. That's it. We're done, right? Wait a second. This isn't the product rule. It's not even close. We don't even have a dy by dx. So what went wrong? Let's see. Let's backtrack. So this line isn't correct. This line isn't correct. Is there anything wrong with this line? No, there's nothing wrong with this line. But what's really wrong is when we differentiated, we said the derivative of ln of y with respect to x. Remember, we're taking the derivative of this whole equation with respect to x. So y is a function of x, as we defined earlier. So we're going to have to use the chain rule, which is 1 over y times, you take the derivative of the inside, which is dy by dx. And that is the derivative of ln of y with respect to x. And now we do the next part of the equation. And this one would be 1 over u, but don't forget we have to multiply by the chain rule and the derivative of the inside, which is du by dx, plus the same thing over here, 1 over v, we multiply by the derivative of the inside, which is dv by dx. Now we have a very good form because all we need is dy by dx on its own. So let's bring the y over to the other side. So we multiply y over here and multiply y over here. We get dy by dx equals y over u du by dx plus y over v dv by dx. What Well, remember from before, we defined y equals uv, so we can substitute that back into this equation. So we get dy by dx, and we substitute y as uv over u, and we can see already that this cancels out. So I'm just going to rewrite it as v. So v by dx plus this y is uv over v, and these two cancel out, so I'm going to rewrite that as u dv by dx. And you can see that this is exactly the product rule. It's just in reverse order. U dv by dx plus v du by dx. And this is v du by dx plus u dv by dx. And the addition sign, the order doesn't matter. So that's what we have. That's the product rule. And now we can do a similar thing with the quotient rule, because we can assume that y is u over v. And remember the first step as before, we take the ln on both sides. So we get ln of y equals ln of u over v. And ln of y equals ln. We split this using the laws of logarithms, and you get ln of u minus ln of v. And now we take the derivative with respect to x, and we get, by the chain rule, 1 over y times the derivative of the inside, which is dy by dx, which is equal to ln of u is 1 over u du by dx, by the chain rule again, the derivative of the inside, and ln of v, don't forget my negative sign, so it's negative 1 over v dv by dx. Now we can do a similar thing again as before. We can multiply y on both sides, so we get dy by dx equals. Now let's see. So this, we can substitute uv for y. So when y goes up here, we can say it's uv over u times du by dx minus uv over v, because y goes over here, and we can substitute that in, and dv by dx. Now, let me just recheck my work. Oh, wait, no, I forgot something. It's not, y is not equal to uv anymore. Made a subtle mistake. Y is not uv anymore. Remember, we defined it as y equals u over v. So now it's different. So we get y, let me write y first to make it clear. Y over u times du by dx minus y over v times dv by dx. dv by dx. And this simplifies when we substitute u over v for y here and here. We get du by dx equals u over v all over u, and this cancels out like that, and what you get is then 1 over v du by dx minus y is u over v all over v, which is u over v squared dv by dx. And now we can take common denominator, and what we see is the common is v squared. So we multiply this side by v on the top and bottom, so we get dy by dx equals. Now the top will be multiplied by v, and the bottom is also multiplied by v, so we get v du by dx all over v squared minus u dv by dx all over v squared. And now we simply just minus the two fractions, and we get the final answer, which is v du by dx minus u dv by dx all over v squared. And just box that and we're done. Let's go home. And yeah, it's very interesting how that works. And the chain rule that we used here, 1 over y times dy by dx, is very interesting because it comes up in implicit differentiation, which I'll make a video on very soon. So thank you for watching. As always, leave comments describing what I can improve or what you liked about the video, and I'll see you guys in the next video. Thank you for watching.